Welcome to the mean value theorem of integration. So the idea here is basically that we want to find some value x equals c whose function value is the average value. So for differentiation, we found something that was like basically the average slope. And here we're looking for the average value. So we want to find some value x equals c in the interval AB such that f of c is the average value of f on the interval. So the question is simply, does such a c exist? Right. So if we recall, the average value is 1 over b minus a times the definite integral from a to b of f of x dx. And so what we get is that the definite integral from a to b of f of x dx is b minus a times the average value. So we could think of this as a rectangle that goes from A to B with height the average value. So I'm going to give myself some more space. So again, this is basically the area of the rectangle. With the width from A to B and height, the average value. So we can kind of draw some pictures just to see that a value should exist if our function f is continuous. So let's consider if we have, here's our function f. And if here is our a and our b. If we pick a line down here and take this rectangle, that area is clearly smaller than, let's just use the smallest value of f. Right? So if we use the smallest value of f, we clearly get a rectangle with area smaller than the definite integral. And so if we use the smallest value of f, then the area of the rectangle is less than or equal to the definite integral from a to b of f of x dx. And then if we do the same thing using the largest value, that's clearly at least as big, right? So if we use the largest value of f, the area of the rectangle is greater than or equal to the interval from a to b of f of x dx. And so presumably there will be some function value that will be just right. So if f is continuous, there should be some function value that will give us that perfect height. So if we, our theorem statement is that if f is continuous on the interval AB, then there exists some C in the open interval AB such that the definite integral from a to b of f of x dx is equal to f of c times b minus a. Or equivalently, such that f of c is equal to the average value of f of x over ab. So f of c equals 1 over b minus a times the definite integral from a to b of f of x dx. So that's an equivalent statement to the one just above. So let's go ahead and do an example. Let's consider the function f of x equals x squared. Our job is to find the value of c, which satisfies the mean value theorem of integration over the interval 0, 10. So we need to first check that f is continuous over 0, 10. And of course, x squared is definitely continuous. Right? Once we have that, let's go ahead and find the average value of f over our interval. So if we want to find the average value of f on the interval 0, 10, we're looking at 1 over 10 minus 0 times the definite integral from 0 to 10 of x squared dx, or 1/10 times 1/3 of x cubed evaluated from 0 to 10. So this is 1/10 times 1/3 times 10 cubed minus 0, or 100 thirds. Once we have that, then our job is to find C such that f of C equals that 100/3. So we are solving x squared equals 100/3. And looking on the interval from 0 to 10, that would be x is equal to the square root of 100/3, or 10 over the square root 3, or 10 root 3 over 3, if we want to put this without a radical in the denominator. And then, of course, we could plug that into our calculator. Oh, technically, this should have been c squared and c equals. So this is our value of c that satisfies the mean value theorem of integration. Let's do one more example. Let's consider the function f of x equals the cubed root of x, and our job is to find the value c, which satisfies the mean value theorem of integration over the interval 1 to 8. So again, the first thing we need to do is we need to check f is continuous. On the interval 1, 8. Well, the cubed root function is continuous everywhere, so we're good. Next, we need to find the average value of f on the interval 1, 8. So we do 1 over 8 minus 1 times the definite integral from 1 to 8 of the cube root of x dx. Or this is equivalently 1 over 7 times the definite integral from 1 to 8 of x to the 1/3 dx. If we integrate that, x to the 1/3 should go up to x to the 4/3, and then we would divide by 4/3, evaluate from 1 to 8. Dividing by 4/3 is the same thing as multiplying by 3/4. So this is 1/7 times 3/4 x to the 4/3, evaluated from 1 to 8. So we have 1/7 times 3/4 of 8 to the 4/3 minus 3/4 of 1 to the 4/3. And 8 to the 4/3, that's just cubed root of 8 and then raised to the 4th power. So we have 3/4 times cube root of 8 is 2, raised to the 4th power is 16. And then this will be minus 3/4. And we wind up with 1/7 times 45/4. Or 45 over 28 for our average value. And once we have our average value, we can go ahead and find the value of C. So we want to find C such that f of C is equal to this average value of 45/28. So we are looking at the cubed root of C is equal to 45/28. That means that C is equal to 45/28 raised to the 3rd power. And then again, We could plug that into a calculator, get a decimal approximation, but that value of C will satisfy our mean value theorem of integration.